So there are around 10 to the power 11. You call some around. This will be very big number. So this much of huge number of neurons are there, which connect and work together. Many of the neurons will work together and complete one task. But
Okay.
yeah, so that is how it is. Looks like this one. A small diagram is the input receivers from where the information from one cell takes from one cell. This is about one cell, biological neuron. This one neuron. So one neuron will connect. One neuron will connect with another neuron. The input of output of one will connect to the input. So it's a
Okay,
input
sir.
receivers. So this is called dendrite.
Okay, sir.
So there are many similar this structure will neuron will work together to complete one task.
Okay, sir.
And that is out of human knowledge actually how total brain works. So, but whatever human knows from that they created a neural network model. So this
Okay,
is
sir.
the information processing cell body.
Okay,
It's
sir.
called soma,
Yes,
and
sir.
axon is kind of a connection sphere, a chemical used to process. The chemical flows
Okay.
along with that information. So whatever you want to raise your hand, so some information will come from the
Yes, sir.
other nerves. Um, so exactly like let's say whatever I understand, like so the information will come here, it will be processed and it will be carried out by axon chemicals, and then
Okay,
it
sir.
will be sent to the outside dendrite. So here may be connected a neuron. Again, here is a new neuron like that.
Okay, sir.
So this is where it works. So and the terminologies are like that. Dendrites, they are tree-like branch responsible for receiving information from other neurons. It is connected to, and we can say like they are ears of the neurons. So they get the information from the outside. So it's a cell body of the neuron responsible for information processing. It's called soma. Axon, like a cable through which neurons send the information. So here the chemical is to flow. Synapse is the connection between axon and dendrite. Axon and this is a neuron dendrite. So this is the synapse. So ANN versus biological neural network is like this. Soma is used to know as node, dendrite as input. You don't remember, I'll see also again. So soma is the cell body. So that is we call as a node. So this node is what you can think of like memory unit. One let's say we need a framework. Generally, when you write a program, what do? You declare a variable, then you save some into something, right? If I have to save a number 2, what I will say where 1 is equal to 2, right? Where 2 is equal to 3 something.
Yes, sir.
And so this way, so when the neural network run, so we require many nodes because all the features, all the records, rows, we have to be saved fast and then processed. So these will be saved in node. Now we cannot declare 100 variables and save it because there is not a neural network. So
Okay.
design a framework has been already built up, a TensorFlow, where the variables, all information will be stored in a predefined structures node, and then it will be processed.
Inside the TensorFlow, sir.
Yeah, that is TensorFlow. That is the framework is TensorFlow. But when we do program, what we do? If I need two variable, where 1 is equal to 2, where 2 is equal to 3, right? Then we get the output is equal to where 1 plus where 2.
Yes, sir.
Neural networks, we predefine the network first, and that networks is uh, body, I mean, let's say is called a node, where there is a particular information is going to be stored.
Okay, inside the TensorFlow. Okay.
Yeah. So that's how
And
it's a framework because
so that means whenever we want to declare a variable inside the TensorFlow, we'll be declaring.
yes, even variable is a very small example. When you load the complete data set or text, so it has to be processed, right? So where it is going to be stored, when it is going to be run by neural network, is the structures nodes we are already going to create before we process it.
Okay.
So dendrites are the input, synapse are dendrites are input. So input is like you understand what is the your data input only,
Okay.
and weight interconnections are weight and interconnections are is known as synapse in biological. So here it is. Weight means the the parameters which used to adjust the equations to make a better output.
Sir, like whenever we after training the model, we'll be getting some weight file, no sir, weight binary file. That one only, sir.
Pardon?
Whenever after training the model, we'll be getting two files, no sir, weight binary file, weight binary file.
No, that is a model. That is a total training model.
Okay.
That has all the trained, I mean, whatever is learned, every model can be do. Every model we can do that create a binary that is called the model. Neural network mostly you have probably observed. Axon is the output. Weight or interconnections, we known as the weight. Uh, so these are some little bit synonymous as well as some difference are there. But look at this equation. So it's all about this is all how it uh, process the information. So let's say these are the nodes. So these nodes will have input x1, x2, x3. X1, x2, x3. You remember these are features. Uh, so x1, x2, x3 all are features. So every row has some information, correct? So row number one, let's say. Uh, if I take it like this, parallelly I open it. So this is the let's say I'm going to process. So this is the row number one. So this is x1, x2, x3, and so on. So the first row it will take. So first row it will take, and all the data will be saved here, and it will be put some weight. I mean initially some random weight, and then summation of w1 into x1, w2 into x2, and so on. All the summation will be done. So, and that is yin. And then this is the informations, and then we have to learn something, right? So this information is learned through a activation function. So,
Okay.
so activation function is what if you compare with this one. Here the information body is processing, and then axon is to transfer it.
Okay.
So axon is a chemical, some chemical will secrete here. But in our computations, once we get the summation of all the information, then we put a learning graph. That is activation function, and this is nothing like a some uh, linear function is there, some logistic function are there, or some tangent function we call. Those we can apply in this, and according to that, to it learns from this model and give output. So ultimately,
We
here
can go
also
impulse
we are
function.
doing math only.
We can go impulse function also. Impulse function. Impulse.
Pardon?
Impulse. Sigmoid.
Oh, that's what. Yeah. So sigmoid kind of sigmoid tangent. All this we'll discuss.
Yes, really. Sir.
So in the above neural networks, the net can be computed as this one. Yin is equal to summation of all the features into weight. And that is yin is the summation of this is inputted as like ymi xi. So, and y is what then? Function of yin. Yin is the summation. So function is what? Activation function. So when you put something, learning the activation function is nothing but again a graphical technique which we implement on it and to get the output. The only things you see that our network is predefined and we create a more defined, we put the structures like this initially and we decide similarly how many the same things will be processed. Then again we create the same layer next, again we create the same layer. And as I say, here it is one thing, the same one things you have to do to make a, let's say, smile only. One neuron will not suffice, one neuron may not sufficient. There may be hundreds of neurons will work together and do that. Right? So, but we don't know how it is happening in our brain. So here also, this is one step. We put an activation function f of yn. What is the output? So then, why it becomes deep? Because the same things when it gets repeated next time, again repeated, so it becomes deep learning.
Deep learning.
Yeah. So.
Okay. Repetition of this one.
Yeah, repetition of this.
Output will be final output will be sum of all these repeated networks.
Repeated networks. So, and not one. So this is one information well process. If you see the first row, x1 first features into weight, in this one, and this is done, you get one output. Then what it do? Because the output during the training, what happened? You tell me during the training we have already output is there, right? So this is supervised learning. I'm talking about the supervised learning. Already you have the output. So you already know the output, but when you train that and do these things, also it will. Let's say we have an expectation of 97 for the first row. Then it's giving you 95. So you will take this 2 as an error. 97 minus 2, 95, 2. So according to that, it will put the error term adjustment. According to the error, it will put the weight adjustment, and again it will run the same things again in the second layer. If I put a straight line here, if I put a straight line and I repeat it, so the next time it will try to improve and get into the 99 from 97. So it will do it repeatedly. How many times? How many times we are going to create a deep learning? So we can define that we want 3 layers, we want 4 layers. Many layers
Sir,
it is.
In some books they'll be giving 15 to 50 layers, 100 to 100 layers, sir. So they'll be creating this many networks, sir.
The many networks is required when your number of features are very large. Number of features are very large. Is
for face synchronization, how many layers have you taken, sir? You have done the first face synchronization.
Face recognition, you take more layers. It depends on. I mean, 4 layers is generally enough. Generally, putting the 4 layers is enough for any model. And then you can do some experiment, trial and error. You can increase it. So we'll see different example, and then we'll be more clearer on that. So in supervised learning, what happened? During the training of AL and artificial neural network, the supervised learning, the input vector is represented to the network, and which will give an output. But the output vector is compared with the desired output, as I say. So if you compare it, so here this is a binary problem.
Using neural networks.
Neural network. So what it can do here also, it's a binary problem. So let's say instead of one is output already trained as a y parameter, it's got 0. Then what can do? It can again do some adjustment and say it will second. 1 second will run the networks. But this is a very simple binary problem. So we don't require much extended network. But before that, let's think of this one as continuous data to give you a more concrete example. So every time this row, desired output and the actual output, if it is changed, so it can do the adjustment. The output vector is compared with the desired output. An error signal is generated if the difference is between the actual and desired output. If there is a difference there, then the error is generated. And on the basis of this error, weight are adjusted until the actual output is matched. So here it is. X input it takes features. First row is run, then the networks, as per the networks, it gives the output. If it is not matching with the desired output during the training, you do the adjustment, and again it will rerun. Then again it will rerun. So how many times will be rerunning? That is, we are going to create the network. Okay. So this is one thing. Then you can think of how many times it is going to run. So in one batch, one iterations, it's going to run the number of rows. Number of rows might be very big. Here it is 10,000. So 10,000 will be training is the 8,000. So it would. So 8,000 will be running in every iteration, every time. So this is a combined effort of saying that 8,000 times when it will run, then what you got the accuracy. So as I say, there is a loss. So there is a loss is there, right? And there is a accuracy is there. So when there is a loss is there, so it will do the adjustment and again done. The next time you will see the error will loss will be reduced. And accuracy will slightly increase. So now think of this one as like the number of rows records you have all will run in one iterations. Then it will do the mean of the accuracy. So every record will have some training already. The target is there. So it will take the mean of 8,000 and it will give you the number accuracy as per it. So out of 100, if it is out of 80 times it is correct, then 80% accuracy. So then understood, right? So then what happened? Then again it will run the same things from the first, and again we'll do the adjustment. And how many times is going to run, so that we can total, we can put it in an adjustment. So epoch is the iteration, so we can put in how many iterations is going to run.
Sir, like you have sent 30 times, so 30 times.
So yes, 30 times is going to run the same things, doing the same things, and improve the accuracy. So that is one aspect, that is during running. But we are at what point? We are going to take the input, giving the input, and we are going to take the output. And between that, what is the activation function or learning graph will be there. That's we are going to provide.
Okay, we are. Okay, sir, you have taken dimensions of 6. Why dimensions of 6?
We'll go to that example. Let's finish this one. So let's think of that whenever is a supervised learning, you require an error signal is there. So every time it will go to adjustment and it will improve the learning.
Okay, that means the number of NP of epochs is the number of times we need to run the program, and based on that, it adjusts the error signal.
Yes, based on that, it will improve the accuracy and reduce the error.
Okay, sir. Fine, sir.
So, due to the training of AN and other unsupervised learning, the input vectors of similar type are combined to form clusters. So, when it's unsupervised, so input vectors of similar type are, we know that we can form a clusters. So there is no feedback because there is no desired output in unsupervised learning. So it cannot do the correct or incorrect. Yeah. So there is no output is there in unsupervised. So we cannot make a correction based on the desired output and the actual output. So in that case, the network must discover a pattern and features from the input data. So here, the network itself do adjustment, and it is not based on the error signals. So there is no this part is not there. Adjustment of the weight. So what is the activation function? So this plays a vital role. So it may be defined as an extra force or effort applied to the input to obtain an output. So if we don't put a activation function, so we are not going to learn anything. Activation function is the learning pattern. So we can apply activation function over the input.
Activation function is a learning pattern.
Yeah, learning pattern because this is we don't have a biological kind of thing that
Sir, then
pardon.
sir, then for image classification, what type of activity will be taken, sir? Image classification.
Oh, there are classification you can take all this out of this ReLU and this two only is there, right?
Hello.
Yeah, this we are already discussing. Right? We are going to discuss it. The number of activation functions and binary and then. See, there are there's a binary and yeah, all the problem we are going to solve. Let's first complete that one. So activation function, two types are there, right? Linear and non-linear. Linear is what? So linear is linear activation function. You can see example like this one. So ultimately, what it is a straight line. But only thing is that it starts from, it can expand into the minus, right? So it's not going to graph like this. And what it look like is a non-linear activation. So it is fx is equal to x, and range is minus infinity to plus infinity. F of x is equal to x. And non-linearity helps makes the graph look something like this. So I mean non-linear means whatever you mean, any kind of shape, right? So now for non-linear activation function are mainly divided into on the basis of the range of curves. Mostly the world of problem is unstructured data, and so in the binary problem, you are saying that this binary problem we are going to use sigmoid or logistic activation function. So based on the range of the curves, so activation function non-linears are divided activation functions. Range means I am saying about this range.
it also looks like in a linear function, but some changes are there.
Yeah, this is logistic, right? Derived from the linear only.
Yes.
Main reasons we use sigmoid function because it exists between 0 and 1.
Yes, sir.
Therefore, it is a specially used model where we have to predict the probability of output. Since the probability of an output exists between range 0 and 1, sigmoid is the right choice. So whenever there is a 0 and 1, so then you can use the sigmoid. And for other thing is like,
So 0 and 1 is values you're talking, sir.
0 and 1 is this one. The y is
Like
y is the target.
like only for binary classification only we can use the sigmoid, sir. Because
Yeah,
in
only
binary
binary you use the sigmoid. For other problem, there is a ReLU activation function is there. And
that
then
means for image, so we will be using ReLU, sir. For images also we will be using ReLU for images also.
see, image also, if you have to find out it's a dog or cat, then it's a binary problem, right?
Okay.
Or three species in the multi-classification.
Okay. That means if you want to say yes or no, then we can go for this one. That's what you're saying.
Yes.
Okay. Like detect a disease or not, like that. If you show the images of a leaf, if you want to detect a leaf is a disease or not disease, so with the 0 or 1 classification, so we can use like that kind of applications.
Yeah, correct. So 10H is hyperbolic tangent, what is called as 10H, is also activation function like a sigmoid, but it's better. Instead of the range is -1 to 1, so it is from -1 to 1, and here it is C, sigmoid, and that's comparison is there. Sigmoid is from 0 to 1, right? And it is 10H is hyperbolic tangent -1 to 1. So what it says there, the negative value will be mapped to negatives. The advantage is that negative inputs will be negative, strongly mapped with negative value. And the 0 input will be mapped near 0.
Positive.
So 0 will be in the 0 only. So here it is, so I mean, if it is negative, it's going in a negative range. So more smooth in terms of that. And this one is most actively used. And any kind of problem you can use ReLU.
Any problem. Okay.
Yeah, ReLU is the most active function in the world. Only by instead of other than binary problem, you can use in any methods ReLU.
Okay, convolutional neural network, deep learning. Yes, I've seen, sir.
Since it is used most in the CNN or deep learning. So ReLU
Why
looks
we are using?
pardon?
Why we are using ReLU, sir, mainly?
Accuracy is more, learning pattern is more good.
Okay.
ReLU is half rectified. Fz is 0 when z is less than 0. And Fz is equal to z when z is equal. So from this, it will be like a kind of this one, right? Tan theta kind of. Fz is equal to z when z is above or equal to 0. From here, it is equal to Fz is equal to z. And here it is 0. Fz is 0 when z is less than 0.
Yes.
So actually, what see, if you see the strong this point only, we call it the all linear regression. All everything follows a linear pattern only. So for all positive values are so. What you can say is like this graph activation function can be used to smooth the point. But if you put what I say that any data when you, because if it is unstructured or something, but we wanted to learn from the binary, and anything, let's say is a price or everything, a pattern is there. A person is taller is always a height is there, right? Sorry, a person having more weight is more big guys, right? A short guy is a more weight. Exception is always less. So this kind of always increasing pattern works in many situations. It gives a good up. The function and the derivative both are monotonic. So what is the zero range is how much is there? 0 to infinity.
Infinity. So we have the ranges
Zero,
from 0 to 1, minus 1 to 1, and 0 to infinity. These
yeah,
are
this is 0 to
sigmoid.
1 and this is 0 to infinity.
Okay.
This one is 0 to
And
infinity.
that
Up to 10 it is showing, but as it is going to increase, it's going to increase more and more.
like infinity means the input can be, that means the range of the input you're talking about, sir. The range of the input is up to infinity.
Output range.
Okay. The range
While,
indicates
while
output. Okay, sir.
here is also one disadvantage is there. Negative values become zero immediately, which decreases the ability of the model to feed or train from the data properly. Any negative input given to the ReLU functions turns the values into zero.
Okay.
So which in turn affect the resulting graph by not mapping negative values with negative values appropriately.
Okay.
But our
Sir,
data and problems, so data and problems are mostly we put as a numbers, not by negative. If you see, if it is an image or if it is a text, or we convert it into binary, we keep the numbers. We can keep in the positive, right? So then you can think as any tangent graph can do more better than others.
sir, generally I want to know where we be giving the negative data inputs, sir. Which any example where you give the negative input to sigma and ReLU. Generally, for any image classification, the pixel values are positive, like 101, 103, based on the pixel density, the RGB color format.
Positive. That's why it's not affecting. That's why ReLU is being used.
Okay, okay. That's what generally for any data sets we don't have any negative values. I think even uh, is
Yeah,
there any
and then
example, sir?
also when you convert, we provided 0 1 text, 0 1 input only.
Yes, sir.
So during our implementation, we'll be using Keras. Why? It's because Keras and TFLAT or Theno, these are wrappers above TensorFlow. So using the Keras make our implementations easy. But
Keras and tensor are widely used, sir, everywhere.
yeah, so if you download the TensorFlow of open source code, this is totally a C++ code. And the Python binding is easy. So we used to bind with Python those methods. We are accessing the neural network using Python.
Sir, now the 1 minute, sir. Now the Python has become famous, but I think 10 years back, 15 years back, everyone were using C++ only. No, so then how they were able to use a TensorFlow, that many lines of codes for when you're building any small image classification.
Yeah, so earlier there was no TensorFlow as a framework. It is not there because when you require much memory, many nodes you wanted to do, and you want to keep in the memory predefinedly, and you want to run something. That's all the concept, right? So
That's
you
good.
are predefinedly allocating the memory, putting in a structure, and you are also applying a functions on that. So then it gives some output. And this processing is happening on that the neural networks in the TensorFlow framework. So we are not declaring the variables to store, but when you say here it is like the data has been let's say this is a X train. So this is the data of X train. So this data